2014 question 22. Which of the following molecules have non-octet structures? Now to do these type of questions, please do not go and start to draw its electron diagrams or to think about its shape or its 3D structure. So it's an MC question, so your goal is to save as much time as possible. So for these type of questions, please think about their electronic arrangements first. So NO2 here, let's take this as an example. The electronic arrangement of nitrogen, you can look at the periodic table. It's obviously given to you in the exam. The nitrogen is in group 5, so it's 2, 5. Atomic number is 7, so the electronic arrangement is 2, 5. The outermost shell electrons here, there are 3 of them. For oxygen, on the other hand, it's having an atomic number of 8, so it's 2, 6, the electronic arrangement, 6 outermost shell electrons. Now here, notice there are 2 oxygen atoms. So I'm going to go ahead and write down another oxygen atom here. Now my next thing is I need to balance, or not balance, I need to make these atoms stable. How can I make these atoms stable? Say for example, I have nitrogen here. How can I make it stable? I'll need to aim for it to have 8 outermost shell electrons, right? So how can it have 8 outermost shell electrons? That's very simple, by adding 3 electrons here. Now how can I make the same thing here? How can I make oxygen stable? By adding 2 electrons so that it becomes 8 outermost shell electrons. And I'll do the same thing for the other oxygen atom. Now the catch is that because actually all of these compounds are, if you notice, they're all covalent compounds. In book 2C, in topic 6, Microscopic World 2, they'll ask you all about covalent compounds. These electrons are being shared with one another. So here, for nitrogen, I need 3 electrons. Where are these 3 electrons going to be shared from? Obviously, they're going to be shared from oxygen. Oxygen here, it has 2 electrons. Now what about the other oxygen atom? 2 more. So that means 4 electrons from oxygen. But do you see the numbers do not balance out with one another? In order for an octet structure in order for a molecule to have an octet structure, the electrons should be shared equally, meaning the number of electrons should be equal from the left and the right. Here, do you notice that there's one electron that's remaining to be shared? Now, if there's any electrons remaining, that means that it's not going to have an octet structure. So this is not following the octet rule. So here, our first option, this is true. It's not following the octet rule. So you don't have to do it. You don't have to write down the electronic arrangement every single time. So you can start to, now that you got the hang of it, you can just write down it's basically the outermost shell electron number only. So phosphorus, you know, it's in group 5, so you can just write 5 there, and this 5 basically represents the outermost shell electron. Outermost shell electron. Okay, so I forgot to write the P. This is 5. It stands for the outermost shell electron. And on the other side, I have Br. Br, bromine, it is in, you can check your periodic table, it's in group 7. And don't forget there are 3 of them here, so I'm going to write down all 3 of them. So the 7 stands for the 7 outermost shell electrons. So you can see now I can save so much time. And see, for phosphorus, how many electrons do I need in order for it to become stable? The outermost shell electrons should be 8, and that means I need to add 3 electrons. How about bromine over here? I need 1 electron to make it stable. So 1 electron for this one, 1 electron for the other bromine atom, and one more electron for the last one. Now, do you see? I need 3 electrons in order for phosphorus to be stable. Where are these 3 electrons going to be shared from? One comes from here, the other comes from this atom, and the third one comes from this atom. Do you see these 2 numbers perfectly match? If the numbers perfectly match, that means they are following octet rule. They're following the octet structure. So here, PBr3, it's not in non-octet structure. So actually, you can immediately check that the answer is B. But let's do for BCl3 as well. BCl3, boron is in group 3. So it has 3 outermost shell electrons. And chlorine, on the other hand, it is group 7. And there are 3 chlorine atoms. So write down for 3 of them. How can I make boron stable? And remember, it's by sharing of electrons, so you can't say, oh, I'm going to lose 3 electrons. No, it does not work that way. That is for an ionic compound. This is covalent, so you need to share it by having 5 electrons to make it 8. And how about the chlorines? For chlorines, I would need 1 each. So 5 electrons here. Chlorine, 1 electron each. 1, 1, and 1. Now do these two numbers match? On the left-hand side, I have 5. I can get 1 electron shared here, 2, 3. That means there are still 2 more electrons for me to be shared, but obviously those 2 electrons are not here. That means it's not following the octet rule as well. So with the help of this, you can see it minimizes all your time, or it maximizes your time, I should say. So it's really efficient doing this method. So your answer should be B for this.